Today we're going to write Taylor series that are not centered at 0, and then we're also going to talk about how you can create new series based on Maclaurin series or Taylor series building blocks. So I think I talked about this at the end of yesterday's lesson, but we didn't do any examples of it. If you shift your Taylor series over to so that it's not centered at 0 anymore, but it would be centered somewhere else, then you're going to evaluate all your derivatives at that new point where you're centered. And you're also going to shift your polynomial over that far. So your new Taylor series still has the second derivative divided by 2 factorial with a 2 as an exponent, the third derivative divided by 3 factorial with a 3 as an exponent, except it's been shifted and it's not evaluated at 0 anymore, it's evaluated at a. Taylor series are named after Brooke Taylor, who was a mathematician, but they were actually first invented by James Gregory, who was another mathematician. So I'm not sure why Taylor gets all the credit. But anyway, we're going to do an example where we're going to find a third-order Taylor polynomial centered at 1 for this function, natural log of x. I'd recommend that you pause and try it before I do it, and then we'll come back together. So pause and then restart when you've tried it. Okay, so f of x is natural log of x, which means f of 1 is natural log of 1. F prime of x would be 1 over x. So f prime of 1 would be 1. Second derivative would be negative x to the negative 2. So the second derivative at 1 would be negative 1. And the third derivative would be 2x to the negative third. So evaluated at 1, that would be 2. Okay, so if I'm going to write my Taylor polynomial, it's going to be p of x is equal to 0 plus 1x. But it's not x, it's x minus 1, because I'm centered at 1, minus, my coefficient is going to be negative 1, oh, I already have a minus, 1 over 2 times x minus 1 squared. And then my next coefficient would be 2 over 3 factorial, which is 6. And then x minus 1 to the third. So if I simplified that out, I would have x minus 1 minus x minus 1 squared over 2 plus x minus 1 to the third over 3. Okay. I wanted you to see centering somewhere else. When you center somewhere else, you evaluate at that point, and then you don't just have x's in your polynomial, you have x minus your center. Okay, Maclaurin series are just a special name for Taylor series that are centered at 0. I don't know why this guy gets his name in the textbooks, because all he did was center his Taylor series at 0. But the moral of the story is that calculus was invented a long, long time ago by a bunch of European white guys with fabulous hair. Although that's not really true, because Archimedes, who was Greek, used limits to estimate pi. Egyptians worked with integral area, and Indian mathematicians took derivatives of trig functions and worked with Taylor series in the 14th century. We just don't have pictures of their hair. All right, so if we're going to find the Maclaurin series for e to the x, that means we want to find enough terms that we can figure out the summation notation for the series. So however many terms it takes you to be able to come up with the general term is how far you're going to do it. And remember that the word Maclaurin series tells you that we're going to be centering at x equals 0. Okay? So f of x is e to the x. Oh, so is f prime. And I don't know how long it's going to take me to see a pattern, although this pattern seems pretty boring, so I think I might be able to get there. And we're centered at x equals 0, so we're going to evaluate all those at 0. I think this looks a lot like a warm-up that you did this week. So if I'm going to use that Maclaurin series formula, it's going to be p of x is 1 plus 1 over 1 factorial x to the 1 plus 1 over 2 factorial x squared plus 1 over 3 factorial x to the third, etc. So in summation notation, it would be 1 over n factorial x to the n, and I'm going to start at 0 so that I get this term here. Okay, so this is the Maclaurin series for e to the x, and the amazing thing about this Maclaurin series is that it's centered at 0 and its interval of convergence is from negative infinity to infinity. So this particular Maclaurin series converges for all x's to e to the x, which means that this is an identity. E to the x is equal to this summation for all x's. This is another example, except this example we're going to get into the idea of building blocks. If we know that e to the x is equal to 0 to infinity of 1 over n factorial times x to the n, if we know that that's true, then if I want to know what x times e to the x is, then I can just multiply both sides of this equation by x. This side of the equation becomes x e to the x, and this side of the equation, because of distributive, you would distribute x to every single term, so that means that our new series would be x over n factorial times x to the n, or you could write that as x to the n plus 1 by combining exponents. So once you have an e to the x building block, you don't have to go through and find all of those derivatives. If you multiply that series by x, then you're going to multiply if you multiply e to the x by x, you're going to multiply the series by x and get your new series. And we can even make things more complicated. We will remember order of operations as we do this, and we're going to say, well, I know e to the x is the summation um, 1 over n factorial times x to the n. So that means that e to the 2x would just be the same thing, except instead of x to the n, it's going to be 2x to the n. And then I know that 1 plus e to the 2x would be 1 plus this sum. And if I want to know what 1 plus e to the 2x divided by 4 is, then I would just take that and divide it by 4. This term would get divided by 4, and every single term over here would also get divided by 4. So the good news is you can now build lots of Maclaurin series easily without doing a bunch of derivatives because you know the Maclaurin series for e to the x. That's the good news. The bad news is you now have to memorize some Maclaurin series. The ones that you have to memorize are going to be handed out to you on a sheet of paper, but I'm going to want you to know the Maclaurin series for sine of x, cosine of x, and e to the x. I also believe the sheet of paper has 1 over 1 minus x on it. That's the basic power series, so that's one that I want you to be comfortable with as well.